Let's take a look at one possible workflow using Git and ARCAD for DevOps. We'll start by dragging a task in Jira from backlog to selected for development. The interface to ARCAD will then create the maintenance report we'll use to track our activity against. We're using Git for source control, so here you see a release branch being created. The release branch will collect changes from feature branches. This is the ARCAD skipper perspective within RDI. ARCAD is tightly integrated to Git. As branches are created, that integration creates and associates versions within the ARCAD change management system. These are libraries on the IBM I for a developer to work in. ARCAD's metadata repository knows all about your production environment. Using that metadata repository, a developer can perform analysis prior to the change. This same information will be used during the build process. With the click of a mouse, a developer can fully analyze a component on the IBM I. Once they've identified a component to change, they can perform a checkout operation. This checkout is retrieving source from the branch in Git associated with this version. There's no lock placed on the source. The source is now in a library on the IBM I ready to be worked on. Back on the Jira Kanban board, you can see the task has moved from selected for development to in progress. This is that interface between ARCAD and Jira. We're seeing ARCAD's centralized version here today. Not much changes for an IBM I developer. They would edit, compile, and test the way they normally do. They can even use 5250. In today's example, we're compiling a physical file. It has dependencies. The repository knows this. It has noticed the logical file in production. It knows the logical is not checked out to the version, so it used the production source and it created the logical in the version library for the developer. It did that automatically. In addition, it created a cross-reference list of all the other related components. These are the components that need to be recompiled before this change is ready for production. With a single click, a developer can recompile all the dependencies. This is a complete version ready for full scope testing. All these automated features taken together are DevOps for IBM I. Here's another example. A developer using Code Checker during the development process to see if their code passes quality standards at this organization. The tool automatically pinpoints issues within the code, positions it to that issue, and allows the developer to change it. Again, this automation is DevOps. Testing can even be automated. Here's ARCAD iUnit being used to test procedures within a module. Remember the buzzword shift left? This is being done during the development process. The tool uses the component to automatically find any tests associated with it. The developer can then select that test, run it, and see if the code still functions properly. They get instant feedback on how well they're doing. If the test completes normally, they'll know it. Remember, Git is being used as source control, so when the developer is done with their changes and testing, they have to update Git with that change. They do that by doing a right-click and choosing an option. Again, this can also be done from 5250. This process puts the developer's changes on the correct branch within the Git repository. We're using GitLab today, but GitHub, Bitbucket, and so on all would work. Here, you can see the feature branch. We'll create a merge request to put the changes from the feature onto the release. You can have any number of feature branches all merging into this single release. This merge process is also going to trigger further automation. In our example today, that automation is going to be a Jenkins pipeline. This pipeline automates all the actions that need to occur after we merge onto the release branch. In the example today, you'll see the pipeline perform another code check, do a build of the components into the release libraries on the IBM I, and when that's done, it will move those components to a test library, and then it will distribute them using drops. In this example, we're going to a UAT machine. Remember, this is only an example. This can support simple as well as very complex workflows. Thanks for listening. For more information, please visit our website at www.arcadsoftware.com.